Welcome back. Now we are going to start with a new chapter, real numbers. This is part 1. So we are going to start with a theorem, Euclid's division lemma. Let a and b be any two positive integers, then their excess unique integers q and r such that a is equal to bq plus r, where r lies between 0 and b. So it looks something new theorem, but it is nothing but a restatement of the long division process which we have been using in our smaller classes. For example, see, you divide 48 divided by 5. So you call 48 as the dividend, this as the divisor, this as a quotient, and this is a remainder. So you write 48 is equal to 9 into 5 plus 3. That is, dividend is equal to divisor into quotient plus remainder. It is exactly the same thing that we are writing. So a is the dividend, as b is the divisor, and q is the quotient and the remainder. And here see, 0 less than or equal to r less than b. That means the remainder is b is the divisor. The remainder is always less than the divisor. So it can be equal to 0. So here in this case, when you divide any number by 5, you will get 0, 1, 2, 3, 4 as the remainders. Suppose you are taking 49 divided by 5. So you will get 9 5s are 45 and 4 as the remainder. And suppose you are dividing 47 by 5, then 2 as the remainder. So you will always get remainders less than the divisor. Now coming to Euclid's division algorithm. It is a series of well-defined steps which gives a procedure to find the highest common factor of the two given positive integers. So we will have a well-defined steps to find the highest common factor. So you will understand this when we do the problems. Now we will find the least LCM and HCF. So we have two methods. This is the normal method that we have been doing in smaller classes. You find the LCM of the three numbers, you write it down like this, try to find the common factor and keep dividing. Here 4 is a common factor for all the three. Then here 3 is the common factor. For here you have common factor as 3 for 12 and 15. So you divide with this. Then 16 is not divided. Now here you take 4 as a common factor for 4 and 16. Like this you will do. And for LCM you will multiply all these numbers and you get this value. So what do you mean by a LCM? This number will be the common multiple for all the three numbers. Multiple, what is a multiple? So multiple means you take a number 4. The multiples of 4 will be 4. 4 into 1, 4. 8. Then 4 into 3, 12. 4 into 4, 16, etc. So we have to find here in LCM, you have to find a multiple which is common for that. So in multiple will be, if you divide this multiple by 4, it will be completely divisible. So LCM also, when you divide the LCM by these numbers, you will not get a remainder, that is completely divisible. So this 2880 divided by 144, you get 20. Divided by 180 you get 16, divided by 192 you get 15. So this is the least common multiple. So the other, you will get more multiples, but that will be all greater than this. So the next multiple will be 2880 into 2. So similarly, so this is called that is why it is least common multiple. For highest common factor, we will write down here it is the factors. So multiple is always a higher number, and here factors, it is always a smaller number. So factors of any number. For example, we will find the HCF of 24 and 12. So first write down the factors of 24. It is 1, 2, 3, then 6, 8, 12 and 24. 12 will be 1, 2, 3, 4, 6 and 12. Now here it is the highest common factor. That is the factor on both, it is a common factor. So you have to see which are the common factors here. 1, but that is not the highest. You will get, now 2 is also a common factor, 3 is a common factor, then 4 is not a common factor, you have 6. Then after that you have 12 as a common factor. So here the highest common factor will be 12. So this is one method of finding HCF. Now we will use Euclid's division lemma to find the HCF. Now we will find the HCF and LCM using prime factorization method. So we found the normal method which we were doing in lower classes. Now we are going to use the prime factorization method to find HCF and LCM. So we have to now write down the numbers into product of prime factors. It's very important. You have to write it as product of prime factors. So 144, you can write it as this, 180 and 192. Now coming to HCF. So again we know that HCF is the highest common factor. Now we have to find what are the common factors here and which is the highest. Now for this we will see which is common here. 2 is common here. And what is the, so 2 is common, but 2 squared is the common factor in all the 3. You cannot take 2 to the power of 4 or 2 to the power of 6 because here you have only 2 squared. So 2 squared, and then here 3 is common in all the 3, and now we have to take 3 as a common factor because 3 squared is not here, you have only 3 here. So now 2 to the power of 2 and 3 will be the common factor, so product of that. So to remember, you can say the least exponent of the common factor should be considered. So 4 into 3 is 12 is the HCF. Now coming to least common multiple, here you will take the highest, because you need the multiple. If you take 2 squared, that cannot be a multiple for this. So that is why you have to take the highest exponent. So here it will be 2 to the power of 6. Then here 3 squared, and then 5 is only in this number, but still you have to take 5 because you are going to find the multiple which satisfies all the 3 numbers. So here you will take all the factors should be considered even if it is not common, and the highest exponent of the common factor has to be taken. So here you will take 2 to the power of 6, then 3 squared and 5, and product of that you will get this as the LCM. Hope you understood this method of prime factorization. See you all with more problems in my next video. If you find this useful, please like it, share it, and leave your comments. Bye for now.